I just realized this mic is set up for someone taller. There we go. Hi, everyone. I'm excited that you're here. This is a crazy big room for the number of people we have. Do you want to move forward? Or do you want to make me feel like, okay? All right, you do you. Cool. Well, I am here to talk about core data. And if you already know core data, then I'm going to suggest you move to the next hall over and watch my friend Jen present about Firebase, because this is really intended for beginners or people who don't know core data or people who are a little intimidated by core data, because everybody says it's like rocket surgery. And you know, yes, when you get into the weeds with anything, yeah, there are subtleties to know. But actually getting started with core data is pretty easy, and switching a project that doesn't use core data to use core data doesn't need to be scary and intimidating. So that's what I want to help you understand today. I want to help you see that core data is just a set of classes that help you do a job. They all have really long names that sound kind of the same, and you got to figure out what they each do. But they're your friends. They work together to do a lot of heavy lifting so that you don't have to write tons and tons of boilerplate to do it. So what is my experience with core data? And hold on, I'm gonna pull off my slides for a sec because they're not presenting the way I want them to. And you see all my, here we go. Well, all right, we'll just play. I will ad lib, I will not have notes. Here we go. All right, so the first time that I tried to, that core data came across my radar, it was because of a project that I wanted to build. So I was gearing up to attend a hackathon. It was the Berlin Geekettes hackathon back in Berlin, Germany in 2013. And I knew going in that I wanted to create a visual schedule app for special needs kids. I used a tool like this with my own child when he was young. It was something an occupational therapist had given me. And as you can see, I had a binder full of pictures. I had this laminated cardboard paper that had a Velcro on it, and I could attach pictures on and off. And as a new parent who always forgot something in the diaper bag, I didn't want to have to carry this around. I didn't want this to be one more thing that I could forget. I didn't want to leave the house and have pictures left on my dining room table that I needed to show my kid on his visual schedule. I didn't want to lose them. I didn't want to have to print new ones. I thought this would be amazing if this were just in my phone, but I don't know how to build it yet. And it wasn't that I didn't know how to build iOS apps at all. I knew how to build something with a table view and, you know, drill down and get a more detailed information from a table view. I knew how to put pictures in collections. But what I didn't know is, you know, once someone enters all of the information, like makes a routine, for example here, that to tell the kid we're going to eat, and then we're going to take a bath, and then you're going to go to bed, I didn't know how to keep that routine around. So if the user, for any reason, closed the app, if the phone battery died and the phone restarted, I didn't know how to make sure that the data was still there, that things didn't get lost. I only knew how to deal with sort of objects in memory. And this is the way that a lot of people come across core data. They come across it first for persistence. And so that can lead people to be confused about what core data is. Is it a persistence framework? Yes, and more. So core data helps you with persistence, but that's not all that it does. And so people can be really confused about that. So that's the first myth I want to dispel. Core data is not just for persistence, although you're undoubtedly going to use it for that. So sort of along with that, my sort of I guess, second preconception that I needed shattered was that I was going to have to learn SQL in order to save my data. I thought core data is going to connect me to a relational database. I'm going to have to write select star from blah, 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 where who knows what. I don't do that very well. I really like working on user interfaces, but I don't love dealing with tables that I can't see. So that was really, really scary for me. And so I thought, okay, I can go to this hackathon and I can find people who can help me build a user interface. I'm pretty sure I'm going to be able to get people who can help me design it and make it look cool. What I'm not sure I'm going to be able to find is somebody who knows how to save things to the device. So I guess I've got to learn that myself. And that was the first time that I learned core data. Now, the course I found at the time was great. This was 2013. It was a lynda.com course by Simon Allardyce. It was amazing, but it's in Objective-C, and it's never been updated since. So unfortunately, this can't be like a 5-minute talk where I'm like, everybody go take Simon's class, because it doesn't really exist anymore. If you want to learn core data in Swift, you have to look somewhere else. So in the end, here is the app that my team built. It lets you set up routines and then sort of walk through the routines with a kid. And it persisted data. Spoiler alert, we won the hackathon. And for years, I thought it was because an amazing designer had designed the user interface, and my other colleague had built, a colleague just walked in. An amazing designer had built the user interface, and that someone else had worked on the UI while I was making the persistence work. And years later, I had befriended one of the judges, and she was like, no, a big part of that was that your app actually worked, that you guys showed that when you just restarted the app over, that the data was still there. Like, you guys didn't make a prototype, you made an app. So thanks to core data, we are here. And I also want to say thanks to my colleague, Josh, we are here. Because this past winter, I had the opportunity at Udacity to rewrite our core data curriculum with Josh. My colleague Josh Svatek, he's amazing. And so what we did was we wrote the course that, like, if past Kate from 2013, first learning core data, was at that state in 2018, what would I want to tell her? The course that we made it's part of our paid offerings at Udacity, but that's also the link to the free version of the course. So, I don't have time to give you all of that content in this 45 minutes, but feel free to ping me afterward, and I will, like, if you DM me on Twitter or whatever, at me on Twitter, I can send you this link and you can go check it out. Okay, so let's talk about core data. So I said that core data does persistence, but it's not just persistence. I believe the words Apple uses are something like data layer management and persistence framework, or object graph management and persistence framework. So what does that mean? Well, it means that it's going to help you manage your data layer. So whatever your model is right now, whatever set of classes you're using to model your application's data, that's going to get replaced. You're not going to use those classes as is anymore. You're going to slightly modify them to make them compatible with core data. And then what core data can do is write that model to disk and read it back again. So here's an example. Like, I think it'll be much more concrete if we look at an example. So here is a note-taking app. You can see at the very left that we have notebooks. So the two notebooks, Haiku and Sonnets. If you drill down to the haiku notebook, there are 2 haiku in there. And if you drill down on one of those notes, there's a haiku. So what do you imagine that the data layer or the data model looks like for this app? I'm actually asking you. What? Anyone? It's too early, huh? So actually the answer is that we would have 2 tables, but let's not even think in database terms yet. If this app doesn't have any persistence in it yet, if I've just like written out a couple of table views and a view controller and I'm passing data back and forth, what kind of data do you think I'm passing? Arrays, yeah, so I could have an array of notebooks, and then each notebook has an array of notes or dictionaries. Right, so I'll show you how we envisioned it for this example. We have a notebook class that has the name of the notebook and an array of notes, so good guess back there, and a note class that just has the text of the note in it, right? So these are 2 pretty simple classes. So getting our data layer into core data is going to mean adjusting these classes so that core data can manage them. Manage is an important word in core data. We're going to let core data manage our data layer. So we have to turn these from regular objects into what are called managed objects. So I'm going to show you how to do that. And it's the scary part of the presentation because I'm switching over to Xcode. And we are, oh, hold on, I have the wrong one open. Here we go. All right, do you all see my code real big? Not that big, actually. Hold on. Yeah? Okay, good. Okay, so I'll just run this app, make sure we're working on the right one. Oh, and we're back to tiny. You want to work with me? No? Okay, demos, man, that's how they go. All right, well, not that important. At least we know that we have, oh dear. All right, thanks for staying with me, people. Oh, because I maximized it, it went over there. Okay. All right, so hey, we have 2 classes. We have a note class that has text in it, that's all it has. And we have a notebook class which has the name of the notebook and an array of notes, right? So step 1 of 2 steps to get our code working with core data is that we're gonna move this model into core data. So in a moment, I'm gonna delete these classes. We're gonna kind of totally replace them. But before I do that, I need to put them in a core data model. So I'm gonna make a new file, and I'm gonna scroll down here. So under iOS, I'm gonna go down, past source, past user interface, down to core data, and add a data model. Normally, you want to call it something more interesting than model, but going for brevity here. Okay, so that brings up the data model editor in Xcode. And what I'm going to do is I'm going to replace my 2 classes that I had with entities in core data. So I'm going to click the Add Entity button. I'm going to add Note and Notebook. Okay, so right now, you can imagine these are kind of like empty classes. They don't have the properties that my classes had before. So let's look at the note class. The note class had this string text property that we would want to have in our model. So I'm going to add an attribute call it text, and give it type string. I'm sorry, I can't make this any bigger. It doesn't resize or zoom, I'm sorry. Okay, and then for notebook, we had the name of the notebook, which was a string. And then we also had that array of notes, right? I'm actually going to represent that as a relationship. So a switch that core data has us do is that instead of just a notebook knowing about all of its notes and that relationship only going in one direction, our note, any note, will actually know about what notebook it belongs to, and vice versa. So relationships in core data are two-way. That's because all of these objects live in a graph, and core data can save the whole graph to the device and back. And actually the easier way to show this is to switch to this graph view where you can see these entities represented sort of UML style. And if I control drag from one to the other, I can set up a relationship between them. So I can say my notebook is going to have some notes, and every note is going to have a notebook. And this relationship isn't quite right yet because right now it's set up as a one-to-one relationship. What I want is for a notebook to be able to have multiple notes and for a note to belong to a single notebook. So I'm going to look in the data model inspector over here. And if I select, let's see, if I select the notes relationship, why are we not seeing the right thing? Hold on. Okay, there we go. If we're looking at the notes relationship, I can change the type from to one to too many. And you can see that this changed to a double arrow here. And the relationship this way is already correct, that a note should have a single notebook that it's associated with. So we're almost there with our data model. The last thing that we need to define is what's going to happen if one of these objects gets deleted. How does that affect the graph? Our original objects didn't really explicitly state that, but in core data, we do. So for the notes relationship, for any relationship, there's a delete rule. And so you have different choices of what should happen if this object gets deleted. So if a notebook gets deleted, what I want to happen is I want that to cascade and for all of the notes in that notebook to also get deleted. Whereas for a notebook, if the note gets deleted, I don't want that to affect anything else, so I just want to nullify this note and leave everything else the same. Okay, so that's actually it. That now that we have this, we could, we're moving it around because I'm really good at typing on stage. Now that we have it, you can see that Xcode is like, you can't redeclare notebook. So what I would do is delete these two classes. And I would actually just have Xcode use classes that it generates from these entities. It's kind of weird because you don't see them. They're not going to appear over here in your project navigator. They're actually tucked away in your project's, in Xcode's derived data. So these get generated from the model, and you're not meant to overwrite them or rewrite them. You can extend them. You can add classes here that are extensions of Note and Notebook, where you can put additional functionality that you want to keep around. But you're always going to let Xcode take care of generating sort of this basic stuff that we've defined in the data model editor. Okay, and this will mess up the rest of our project for a little while. I'm just going to show you, let's see, did it get mad? Get mad yet? Try to run, there we go. It gets mad because it's saying that we, for example, here, are not passing in a context when we create a notebook. Okay, so this leads us to step 2 of setting up your project to work with core data. What's a context? I haven't told you about that at all. So let's switch back over to slides. Oh, okay. Let's watch this slide again because that animation was dope. All right, okay, cool. All right, we've kind of covered that, okay. Cool, all right, so step 2 is that we are going to set up the core data stack. This, as I was starting to tell you at the beginning, is the set of classes that work together to kind of put the infrastructure in place for us to be able to make very, very simple calls to save and fetch data and have that graph managed. So, all right, so who are the players here? You're going to have one or more managed object contexts. I'll tell you more about that in a sec. You're going to have the managed object model, which is the thing that we just defined. We did that. You're going to have a persistent store coordinator. And finally, a persistent container. All right, so let's talk about each of these in turn, starting with the managed object context. So that's an instance of an NS managed object context. And that is where, whenever we instantiate a new notebook or a new note, that's where these things are going to kind of just be in memory in our application. The term that Apple uses is a scratch pad. It's like a scratch pad. I have racked my brain. Josh and I racked our brains. There's not really a better analogy. Like, do you use a scratch pad in your daily life? Who even knows what a scratch pad is? What they mean, okay, some people here know, wait, I just saw a couple hands. All right, okay. All right, so you can explain to me after what a scratch pad is. I think of it a bit like a draft. It's not a perfect analogy either, but it's a place where I can manipulate the objects. I could set their properties. I could create new ones. I could delete some. And it's like a working draft of what I want to happen, but nothing's going to change in my user interface or down in the data store unless I actually intentionally make that happen. So it's a place where I can kind of like play around with things and change them, but I could also like just revert all of those changes like in one fell swoop if I want to, and be just kidding, like don't show that in the user interface, don't save that to disk. All right, so that's what they mean. It's a place where this is just sort of when you're working with the objects in your in memory where your changes are going to happen. They won't affect the UI and they won't affect the store. Yeah, so here we have some changes. See, I'm working without notes, people. Here we have some changes, right? Like you've modified something, you've deleted something. And you could save the context, calling managed object context.save to get it to the persistent store if you want it, to get it to the external store. Or you could call context.rollback and roll it back. And that's why, in order for us to work with managed objects, Xcode was complaining that we were instantiating a notebook like this without telling it what context we want to manipulate that object in. So we can no longer call just the empty constructor. We have to call a constructor that we get now that our node node and notebook are managed objects. Oh, I should have said that the classes that Xcode auto-generates for us from that data model, they subclass NS managed objects. So if you were wondering why these things are, why I had classes and not structs in the first place, it's because we need to be able to subclass NS managed objects. Okay, and so just to be clear, these sort of yellow arrows mean like this does not happen automatically. Whatever I'm doing, all of my work in the context, it doesn't automatically get saved to disk and it doesn't automatically update the user interface. So I have to do that intentionally. Okay, so that's the context. I said that we can have one or more of these things. By default, you get one that works on the main queue, and you can create additional contexts that work on the background. So if you have long tasks, you can send them to another context. All right, so the second pillar here is the data model, and you all are experts at this already. You're very familiar with it, having converted a non-core data model into one, and that's what it ended up looking like. Or this model is a little more complicated. There were creation dates for the node and notebook, but basically the same. So inside of our project, this is represented as a .xc data model D file. It gets compiled down to an MOMD file, which is what ships with your app. And this model is going to be used. This is sort of the translation guide for other parts of the stack to know how to take data that's saved in whatever format the underlying store is using to populate it into objects and to like slurp it back down into whatever form it needs to be in the external store. Okay. Third up is the persistent store coordinator. This is the class that, it's an NS persistent store coordinator, and this is the class that has connections to one or more persistent stores. So core data by default can handle a few kinds of stores. There is a SQLite store that it can write to. It can also serialize out to like flat files if that's your jam. It can handle an in-memory store. So you may have one or more stores externally, and the persistent store coordinator is the one who knows about them. And the persistent store coordinator is the one who speaks SQL or whatever else you need to speak to get your data from objects down into that store. So as iOS developers, we will never, using core data, we'll never use SQL commands like select star from big table. What we do instead is we use something called fetch requests, and we can use predicates to sort of specify, I want all of the notebooks that have these kinds of notes, or I want all of the notes that have this property. So for me, as someone who doesn't like to, who doesn't want to have to be an expert database administrator in addition to being good at UI development, that's really comforting to me. Okay, so I was saying that the store coordinator knows about the store. So it's going to work with the model and the context to get data back and forth from the saved format to the format that we need when our app is running. And I don't have my notes, so I don't know what words go with those arrows. But yeah, the persistent store coordinator will look at the model, that sort of UML-y stuff that we defined, and it's going to say, oh, okay, I have this data, and the model tells me how to translate that into actual objects, and then when we call context.save to save data down, the same thing will happen in reverse. Okay, and our last frontier is the persistent container. So this is a class that was added somewhat recently, I think 2016. This class is meant to handle most of the boilerplate stack setup that you would have to do to get all of these classes working together. So it has a connection to each of these other things that we'll need, meaning that when our app starts up, we can just create an instance of a persistent container and pass it around. So we want to create this as our app is starting up before the UI is loading. So somewhere in the app delegate lifecycle startup is when you want to create your persistent container. And Apple actually notes that this class is meant to be subclassed, so you can use it to keep the connections to your context and model and store coordinator. But you can also add additional functionality inside of a subclass to corral any other core data related functions, like for saving to the device or for fetching certain subsets of data or whatever you might have. That's a great place for that to live. There have been a couple blog posts recently going back and forth about what the right way is to pass the persistent container around. Some people like to pass it around itself. Some people like to have it housed in another class that gets passed around. Some people say, like, oh, don't pass it around, just pass your objects, which know about their context. There's not really consensus on one right way to me. Yeah, there were two sort of very, very conflicting blog posts recently by pretty opinionated people. So I don't have a best practice there, but Apple, in their documentation that was updated seemingly this week, suggests that the container is something that you should pass from class to class to class. So don't pass the managed object context around, pass the container around. If you've housed that in another class, pass that housing around. The container needs to be anywhere in the UI that wants to access core data. It's the long story short. Okay, so a persistent container comes with some functionality built in that we want. I should say you instantiate it by passing in the name of your managed object model. And the first thing that you do with it in your app delegate is that you have it load the persistent stores. So you give it the name of the model, which is how you connect it to the model. You tell it to load persistent stores, which is kind of how it gets connected to the store coordinator. And then it comes with these built-in sort of helper bits, reference to a view context. So that's the managed object context that works on the main queue that we can just use and start calling. If we create our new notebooks and notes and pass in that context, then we can do our work with them and call context.save, and all of that will get saved to the device. Cool. So that's the persistent container. And hold on. There we go. We're coming back. Okay. So I felt too nervous to actually write this code in front of you today, and I decided to just show you this snippet from the new Apple documentation about converting your app to using core data, just to show you that setting up the persistent container is only a few lines of code. So here, let container equals ns persistent container name data model. That data model is whatever name you named your model, right? So I just very lazily named my model 10 minutes ago. So whatever that name is, you pass that in, and that's going to connect the container to your data model. And then you call container.loadPersistent stores with a completion handler. And that in that closure, you can do anything that you want to happen once the stores have been loaded up. So I think we have 5 lines of code there. In the course that Josh and I built, we wrap this in a data controller class, and we end up passing the data controller class around. It's one way to do it. You don't have to do it that way. Cool. So since I'm not typing, I think the only one last thing that I want to share with you is that just this week in preparing this talk and revisiting this presentation, I thought I would take a snapshot of the core data documentation that's existing, because it's like it was, up until last week, a pretty horrible wall of text that I felt didn't explain these relationships between these 4 friends. Oh, these 4 friends very well, right? Like, those 4 classes are super helpful and easy to get up and running with in your app. And up until last week, Apple, I think, was not showing core data like with its best profile. But it seems they've just redone the core data documentation, which delights me. There's still no images. I'd like them to kind of diagram it out and show us what those relationships are. But they've definitely completely revamped and are explaining things in much, much simpler terms than they did before. And they have these articles like making core data your model layer, which didn't exist before. So it seems like Apple is really working on making this easier for developers to understand, which surprises and delights me. And I hope that all documentation that we see coming out of Apple about these things will be equally surprising and delightful moving forward. So that is it. Like I said, I will, here, let me just put this slide back up in case people want to go check out the class that Josh and I wrote. You can get it for free at this URL, or you can sign up for other Udacity things. But I think if you're in this room, you may be beyond our learn Swift from scratch stuff. So I'm sending you straight to the free course. And if you have any questions, I dislike taking questions from the stage, but I am happy to talk to you if you just come up to me. So thanks, and I hope you enjoy the rest of your day.